Right, last slot of the day. I'm the only thing standing between you and your train home, so I hope you still have some energy. I do. All right, so a bit about me. My name is Romain. I'm an Android engineer and backend engineer. I've been doing Android for about 14 years, and half of it both on backend and Android. I worked for a few companies, and now I work for Monzo based in France. I'm a dad, I'm a husband, and yeah, as I said, I'm based in south of France, a lovely city, if you're not a duck or a goose, because we make duck confit there. Yeah, today I'd like to talk about collaboration. Title mentions backend engineers, but many tips apply to all kinds of engineers, to be fair. The idea is basically how can we, as engineers, improve our working behaviors to make things better. Simple, right? And cool, so yeah, I'd like to start with a simple question. What was it like when you started making apps? You may have been around for a year, 5 years, 15 years. It doesn't matter to me, to be honest. Things are moving so quickly in this industry. Even AI has changed so many things in just a year, right? So just think about it, and I don't know, the first thing that comes to my mind is technology. Technology has changed so much. When I think about how things were 15 years ago, well, I was using Eclipse as an IDE. It was painful, to be honest. I was using Java as a language. Jake Walton's library, Action Bar Sherlock, was like the Jetpack compose of the time. I had nightmare of the activity lifecycle. I don't know if you do too. There was no Gradle, no Kotlin, no Compose, no Dagger. It was basically you and your lovely Bev on Android SDK 2.2 Froyo. But there was not only I think technology that was different at the time. It was I think interaction with the outside the Android world was also quite different. Well, this is not an accurate picture of 15 years ago, but a common pattern at the time was to have teams around specific specializations. So you'd have mobile teams or even Android and iOS teams, backend teams, designers, and as a result, you would have backend providing an API, Android doing Android, iOS doing iOS, and I think we were kind of working in silo, and although this may work nicely for small companies where you have one of each, it was not very scalable, and we would see a lot of teams not using the capabilities effectively. An example is you would have mobile teams introducing external cookie cutter solutions to address their problems instead of investing time to build it properly. For example, I'm taking, I don't know if you know Pusher as an example, which was kind of a solution provided by a company which would allow you to send push notifications. They would allow you to add some libraries on the backend side, on the client side, and then poof, you would have push notification. Great idea, but when you think about it, sending push notification today is not a complicated problem. It's a solved problem. And if you put your engineering team thinking about it now, today, you can actually solve that in-house. You don't need an external tool to build it. But yeah, different times, things were not that simple as well at the time, and well, mobile was not the main focus as well. And I think things started to change in 2014. Well, that's how I see it. I think Spotify came up with a now famous model, which is cross-platform teams with squads and tribes and guilds. So you'd have squads with usually a product manager, designer, and engineers with of all kind, a QA. And then you would have tribes or collectives to drive to sensibly group squads. And finally, you would have guilds to address problems. That's it across the business. And I think this was a groundbreaking change in the industry. Individuals started working beyond their specialization. The focus was no longer on the domain, but it was on the actual product. And today, this is a standard, as you know, in the engineering world. A lot of companies have adopted similar setups with cross-platform teams. Well, cross-platform teams got everyone closer, right? But was that all we need to build great products? Well, you might be wondering what this orchestra is doing in my slides. Well, you're looking at some of the best musicians out there. Every instrument finely tuned, every role clearly defined. But if they don't listen to each other or come in with the right attitude, it's not music. It's just noise. What I'm trying to communicate here is that you may have the best setup with cross-platform teams, well-defined roles, very capable people. But if they don't come with the right behavior or the right intentions, you're missing the point, basically. And when we think about the right skills or the right behavior an Android should have, the obvious one is the platform and the language knowledge. Like I'm an Android engineer, so I should know about the Android SDK. I should know how to write in Kotlin. But there's more to it, right? Like we all have some other skills like communication, mobile UI, UX, knowledge, etc. Right? Like there's so many layers to it. So if you place your main knowledge in the middle here and your softer skills on the side, you get your T-shape. Like there's this concept of T-shaped engineer, which was introduced actually a long time ago, and everyone in the team brings some form of skills, right? And as a result, like to build a big team is to actually combine all those capabilities. So it might feel like very abstract, but to me, like it's quite important to understand, like what you're good at and what are your skills. To actually like see if something is missing around you. And I recently found out about this concept of balanced engineer, which I really like. It was introduced by Brittany Ehrlich, who has like a really good newsletter, by the way. Like, totally recommend reading. A balanced engineer is a generalist at heart, someone who knows that the best solutions come from mixing different skills, experiences, and perspectives. They understand that great engineering isn't about mastering one tool or framework, but also about connecting the dots from code and system design to product thinking, communication, and collaboration. So it's basically very similar to what we're seeing more and more in job adverts. Like we're seeing a lot more product engineer job adverts out there, and it was mentioned this morning during the panel. I think we're always seeing a demand for generalist engineers who bring a set of tools to solve a product-related technical problem. And I think like the lines will get even more blurry with AI, where an engineer could actually do things they wouldn't have a clue to do the day before. So yeah. So I've thrown you like a lot of buzzwords here, and you might be wondering like, if you're going to learn something from this talk. Well, I'm not promising anything, but let's talk about like practice now, I think. Let's assume that we're building a new feature for our app, and let's see how you can apply this behavior for each step from the beginning to actually shipping that feature. At Monzo, we like starting with a proposal or RFC, for those who are not familiar with the term proposal. RFC is a request for comment. And basically, a proposal is a nice way to draft out the needs of your projects before jumping to its execution. RFCs are older than the web, and in fact, they actually help build it. So just something that I really like when I was researching for this talk, I found out that the IETF, Internet Engineering Task Force, maintains an index of all the RFCs they have been submitted and discussed since 1969. They actually like built the web as we know today. So following this link, like you will find like basically loads of technical decisions that made the web as we know today. And they also have this tradition to publish some joke RFCs every year for April Fool. So this one actually introduced the 418 I'm a teapot HTTP status, which can actually be found in some HTTP libraries today. Not super interesting, but I find it interesting. So there you go. So an RFC doesn't need to be complicated. It doesn't need to be designed to build the web. It can actually be here just to discuss something that you want to change. And there's many templates out there, but like I think the core section that you need to have is basically give some context why you're proposing this change, what motivates you to drive this change, and then another important section should actually describe like what you're proposing to change. This is the core of your proposal. But also, it's also important to describe like if you thought about like any kind of alternatives along the way, because that way you can actually say like, well, I haven't considered this because, well, my solution is better because X, Y, Z. And then, yeah, you can also include any kind of details about like, security, testing, whatever makes sense for your project. Why am I talking about proposals here? Well, I think it's a nice way to propose new ideas. It empowers anyone to do so. And it makes you think through the problem before you actually implement it. And it's a great platform to discuss it before you build it, so you can actually discuss that with backend engineers or any kind of anyone who could have a say to this. And when you start building, you actually know that everyone is aligned on that decision. So, well, it's safe to go that way. And yeah, finally, as I mentioned earlier, it builds up some kind of documentation. You can always look back in the future why we made that decision. Sorry. So yeah, naturally it's going to build that documentation. Yeah, when writing a proposal, I like putting my my researcher cap and check out the kind of existing code in other systems, iOS, Android, backend. It's always interesting to understand what's in place and to learn from it. With that researcher mindset, you get to weigh the pros and cons of different options. Without that proposal stage, it's easy to just like jump into the implementation by just picking one option, which could work sometimes, right? But the problem is that usually it would lead to tech debts if you haven't picked the most optimal solution. Right. So I think one section that is usually quite core to a feature change related proposal is an API change, right? Because it's quite rare that you build a client that just doesn't talk to the backend nowadays. I think API design discussions are especially interesting in proposals. They can often be a good place to agree how the overall system will behave with the change you're proposing. When I refer to API, I mean backend API, but to be fair, it could apply to any kind of API that you need to build. It's quite common to see an API contract like something that belongs to backend engineers. As I mentioned earlier, like working in silo, when you have like backend team, Android team, iOS team, etc. Like the backend engineers provide an API, and I think it's still true today. Like a lot of people still believe that like API is a backend thing. Problem with that approach is that the API might not be tailored to the application needs because it was not thought based on the actual UI that is being built, if you see it this way. Considering the API contract like something that sits between the backend and the client usually results in a more constructive discussion. At the end of the day, it is a contract, right? So all parts should have a say on how it should behave. One thing I've seen particularly effective to enforce that API contract abstraction is to use OpenAPI, previously known as Swagger. OpenAPI offers a way to define your API definition as a YAML file and to generate the backend and the client code using generators. There are plenty of generators out there, so for all languages and frameworks, so you will find something that works for your system. And with that, the nice thing about that is that the YAML file can live in a completely separate repository, right? And be maintained by all engineers. So it increases collaboration. It makes that not a backend thing. Depending on your process, you may even want to discuss API changes over GitHub PRs instead of on a proposal. So yeah, whatever makes sense for you. Diving more into an actual real-life API, I was looking at the droidcon app, and I was like, just as an exercise, I just thought about how I would build an API for this, and like the first thing that comes to mind is like, well, we're displaying events here, right? So let's just have an array of events, and that kind of makes sense, right? So you would have like, the general gist of like timestamp and IDs and so on. So that's like what is called a general purpose API. You're focusing on the domain, which is totally fine, to be honest. But it's quite backend oriented, right? Like you're thinking about the actual entity. You're not really thinking about your UI here. And the problem with that is that it's going to lead to inconsistency between client platforms, because, well, it could be interpreted different ways, right? It could, and the UI might look different, and that's not what you want. So there's another approach, which has been around for a while now, Backend for Frontend API. It's essentially like the gist of it is like, instead of thinking about your domain, you're thinking about like your UI. So here I'm not seeing only events, I'm actually seeing like, tabs, and in each tabs I have got items, and each item I have like text, and that's it, right? So basically try to format things as much as possible on your API side, so that your client doesn't have to think too much. And like, the reason why I really like it is that it makes your client even dumber. So if you have to fix something, you can fix that on the back end, and you don't have to make a new release. And it works quite nicely with the remote compose paradigms that was shared yesterday, which is kind of moving that UI layer outside the app. And I think we're moving like more and more towards that. So what is a backend frontend? Well, it's basically just a backend layer that sits between your clients and the microservices that you have on your backend. And why am I bringing this up today? Well, I think it's also a great tool for collaboration, because at the end of the day, well, this is a backend layer, so you're going to have backend engineers maintaining it, but, well, it's delivering UI-related stuff, so they might not be really comfortable with that. So your client engineers will also like help with that, will also come up with solutions and like the best kind of intention to return that to the client. So at the end, you're gonna bring engineers closer by just building that new layer. And as a result, you will have like a product that is much closer to what you want. And well, on the previous slide, you might have noticed something that I want to point out, which is URIs. I think it's a very underused thing on Android and iOS for navigation. Like, it's quite common to see navigation being driven by the backend, but I don't think navigation is very, very, very much driven by the backend usually. So, well, what is a URI? Well, a URI can open any kind of screen from outside the app. But actually, it can be used internally, right? So if your API returns a URI saying, well, this item should open the deep link myapp /event ID, then the client will know that it's going to have to start that other screen. And why is that useful? Well, actually, it moves that logic away from the client. So it means that if you have to change something, you don't need to make a new app release. Cool. So we have a proposal. So everyone should know exactly what they need to do, so we can go and implement the thing. Well, now let's think about let's think back about our balanced engineer, product engineer, someone who's basically curious and willing to contribute across the stack. That kind of mindset comes with a few superpowers, because if you know how to make a change on the client and on the backend, well, you will have a better overview of the whole system. So what's missing, what could break, what is covered by our testing. When something breaks on the other side, they don't need to wait for someone else to fix it. They can just do it themselves. So if you haven't already, have a chat with your favorite backend engineer and book a pairing session with them. You could even do a follow-up reverse session and teach them how to do Android. It's always good to take some time to do that. At the end, it's going to help you on the longer term. Another way to make a first step in the backend world is to regularly check your fellow backend engineers' pull requests. See how they make changes. If something is unclear, ask questions. Make suggestions. Git can be an incredible learning resource. When there's something I don't know how to do, I just search through the code base if there's not a similar example. And if something in the code doesn't make sense, I do a git blame, and that's the case on any platform I work on, not even on Android. So yeah, just use Git. It's just there. Another way to get other engineers closer to your Android pipeline is to polish your onboarding documentation. Some companies provide an onboarding documentation for new joiners to get familiar with the things specific to the code base. For example, architecture, module convention, CI pipeline, release process, whatever makes sense to your code base, whatever is specific to your code base. At Monzo, the onboarding documentation for each system, backend, Android, iOS, web, is so polished that it's not only used for new joiners, but also for engineers on other platforms. And as a result, we have a lot of mobile engineers who today work on the backend. And it's actually a requirement if you want to contribute to the backend at Monzo. You need to go through the onboarding first. The cleaner your documentation is, the more appealing it will be to engineers to be on other platforms. All right, so it's 2025. I don't think I'm allowed to give a talk without mentioning AI. But yeah, jokes aside, it's actually a great opportunity for teams, right? Invest in AI if you haven't already. Set up some simple agent rules to automate the boring bits. Make MCP integration easy. For example, Figma MCP can help backend engineers experiment with UI without being UI experts. Yeah, AI is just a great way to learn a new technology. And this one might be controversial, but I think the more tools you share, the easier it will be to collaborate with other engineers. For example, it's quite common that mobile engineers use their own solution for continuous integration, like Bitrise being a great example. While those tailored solutions provide value, taking the extra step to share the same CI helps bringing engineers closer together. With very low context, a backend engineer could help an Android engineer fix their Circle CI, for example, a pipeline as they would use it for their tools. So think about like the tools that you use on a day-to-day basis and see if there's something that you could actually share with other kind of engineers. Cool. So we've built the thing, and it's now time to run a test party. Sorry, Mr. Bin, it's not that exciting. Testing party. What is a testing party? Well, it's basically you get everyone who contributed to that feature in a room for an hour also, and you try to break that feature. So everyone could be, it doesn't have to be only UI engineers. It can be like, backend engineers, product manager, designer, whoever have a say, because at the end of the day, while you may have made the UI related change, you're not the only one who actually worked on this. So why is that good for collaboration? Well, I think it's because, it shifts ownership away from the client engineer. It's quite easy as a client engineer to feel responsible for a feature, but you don't have to. And I think testing party plays a good part at actually moving that kind of ownership. Right, so the feature is built, it's tested, we can now ship it, right? Well, during that phase, we usually discuss how it will be rolled out. And again, there are various options which benefit from a good discussion with backend engineers. And I'm going to go through them just to give you an example of what kind of discussion you can have with backend engineers at this stage. Well, the one way to ship a feature is just to simply make the change and to bundle it with your next release, right? This may work for a simple enough change, but it's risky for anything bigger. I would call that YOLO mode. Say, for example, you ship a new feature in version 1.1, and then you notice that 1.1 is buggy. Your only option is just to ship a new updated version 1.2. The issue with that is that the fix may take a bit of time to get to customers. Some users may have disabled automatic updates, and they will be stuck with the bug forever. And if the bug also impacts the backend, your backend will have to live both with the old code and the fix. So not ideal. Well, one simple and quite known way right now to fix that is just to use a feature flag, right? So if your backend provide a feature flag that says, hey, my feature is enabled, then you can have some logic on the client that says, if my feature is enabled, just do that. If not, just don't. And then if you notice that if you enable the feature flag for version 1.1, and then you find the bug on 1.1, then you can just disable it, and then you're safe. 1.1 is sorted, and then you can roll out version 1.2 and just enable it for version 1.2. So you're fine, right? Well, there's a slightly better version of that because, well, the problem is that you're going to have to clean up the code down the line, right? Because you're going to have some logic on the client that says, hey, if my feature is enabled, do that. That will need to be cleaned up in version 1.3. So there's like another option, which is like having that feature flag logic on the backend. And coming back to the solution that I was talking about earlier with like a backend for front end, basically that layer that drives the UI from the backend. Well, if you have that, then you can move all that layer, that logic with the feature flag condition on the backend. It's basically a great way to fix this. One problem with this is that you're still going to have to do some cleanup on the backend because, well, you still have some logic at some point, right? And the problem is that from the backend perspective, you still have to maintain some code that will be used forever for very old version and for newer version. So how do you fix that? Well, there is something called version deprecation, which is whenever your app launches, it checks against the server if its version is deprecated. If I'm deprecated, then I show a full screen that says, hey, force update the app. And if that returns false, I just proceed as usual. And the backend will increment this version regularly so that, for example, versions for, 6 months ago or older are always deprecated. So every release, you just shift that 6 months window, and then older versions can just be considered as done. Right, so the nice thing as well on the client is that it means that less app versions needs to be maintained. You can only focus on the version from the past 6 months. And on the backend, you can clean up that feature flag logic that you had previously. And yeah, there are other ways to improve collaboration across the board. One simple way is to do dog fooding. It's basically shipping nightly builds internally every night. Say that you have like some kind of internal testing channel on the Play Store, and you share that. You invite everyone for the company to test that app. Then you will increase the testing pool before it actually reaches out to customer. And why is that good for collaboration? Well, again, it shifts ownership away from you as an Android engineer. Because in many companies, like Android engineer are the sole testers until the app gets released to the Play Store, which is not amazing, right? Because, well, you may have, 5 Android engineer, 10 Android engineer. That's a very small number. If you actually provide that, if you enable other people in the company to test the app before it reaches out to customer, then it moves away that ownership, and it empowers other people to play around with the app before it goes out. So basically, you're going to find bugs before people from outside the company play around with the app. Another way is to have like master and pull request builds shipped to the Firebase app distribution channel, or anything that you use on a day-to-day basis. Why would you want to do that? Well, again, shifting ownership. Like say that you're building a new change for your feature, then it's ready, it's on a pull request, and you can just tell, instead of testing it yourself, you can actually tell your backend engineer friend, say like, okay, well, it's on Firebase app distribution, you can just install it on your phone and play around with it. So again, you're not the sole tester of that change. And the thing that I really like as well to share here is to have like an internal command line to install your app easily. At Monzo, we call it Droid. It's basically an internal tool which does a lot, to be fair. It gives you a way to install a certain release or a certain branch. It can log a user in, log out, set up proxy, whatever makes sense for your use cases. Why is that useful for collaboration? Well, it's a nice way to make certain capabilities available to engineers with a very low context on the system. So basically, a backend engineer who would like to test the app is now empowered to do it very simply by just running these 3 words and plugging in their phone. So look into building a droid command if you don't have that already. And we also have like another solution to solve the other problem, which is client engineers trying to test some backend related stuff. We call them recipes. So we have like a web UI to actually create some stuff that, as a client engineer, I wouldn't know how to create a new user in the Monzo context, like set up their balance on staging. This is all abstracted for us. Like you just have like web UI that has been built by backend engineers who can actually, with just text boxes and check boxes, simplify all that. So look into like building some solutions like that, because it simplifies that bridge between client and backend engineers. Yeah, sometimes we like putting gates between us, and it's easy to label ourselves. I'm an Android engineer. I'm a backend engineer. Through this talk, I wanted to give you a taste of what it's like to open these gates. We sometimes see these tips and techniques as ways to be more productive, but it's also a great way to learn how to enjoy the ride with our colleague earlier more. So sorry, I went very quickly, but that's it. Thanks. And I think we may have some time for questions if you have any. Yep.
Talk about before the OpenAI specification.
Yes.
Right? Yeah. In the situation of backend for frontends,
Mm-hmm.
the OpenAPI specification should be there should be two OpenAI specifications in a frontend for backend and general definition of the APIs.
It depends how far you want to go, right? But like the way we've been using is only between the apps and the backend layer. But you could also like build a contract between your backend for front end, and it depends how far you want to go. But I feel like it also depends on your kind of communication protocol you have on the backend, because it could be something else, right, than JSON, or well, I don't know. To be honest, OpenAPI could produce something else than JSON. So I don't know, but yeah, many solution. The words is mad. Yes.
You don't call for the backend for front end.
Sorry?
You don't call for the backend.
Backend engineers on our side. But yeah, it actually makes sense to, yeah, you could have client engineers. But the problem is that like on-call problems are usually a bit more backend related. Yeah, might not be always the case, yeah. Yep.
What's your onboarding format for backend? If an Android engineer wants to contribute to backend, what's the format you manage the onboarding?
Yeah, it's a good question. So we use Notion at Monzo quite heavily. It looks a lot like a tutorial that you would find online, like blog post explaining how to step by step configure a new service, and it's on the backend side. It's really, I think it's really well done. Where like you have to create, I think, some kind of fictive service to provide lunch for, like it's something that doesn't make sense anyway. But like, that actually covers all the things that you would do on a day-to-day basis as a backend engineer. And there's like different steps as well. You don't have to go through all steps because it goes like deeper and deeper. But if you go through like the first steps, you're already kind of quite capable. There's some kind of barrier as well about like the language, which if you're not familiar like with the technologies that you use on the back end, well, that's another thing to learn. But I don't know, like we know I think as software engineers, like we shouldn't be afraid to, well, the same principles are used in any kind of languages, so it is possible as well. Right. Well, thanks for listening.